Good morning, everyone. So today we will study fourth quadrant chocolate drive. Okay. So this drive will work in four quadrants. This quadrant one, quadrant two, quadrant three, and quadrant four. Okay. So this is multi-quadrant drive. Okay, which will work in first, second, third, and fourth quadrant. Okay. So what we have here, we have two A-type chopper connected in parallel. Okay, so it has got four chopper switches: switch one, switch two, switch three, and switch four. Okay. Switch 4 and 4 diodes which are connected in parallel to this chopper switches. Okay, this is D1, D2, D3, and D4. Okay, so these two A-type chopper. So this one A2 quadrant, this A-type chopper, left side A-type chopper, and this A-type chopper works in another two quadrants. Okay, so this quadrant, this A-type chopper is CH1 and switch 2. So this will be in moving mode. This will operate in moving mode, and switch 2 will operate in second quadrant, that is reverse regenerative way. Okay, and switch 3 and switch 4 will operate in quadrant 3 and quadrant 4 respectively. So switch 4 will operate in third quadrant, that is reverse motoring, and switch 4 will operate in fourth quadrant, that is reverse regenerative. Okay. So this is circuit diagram of four quadrant chopper drive. So input voltage is V. There are four chopper switches: CH1, CH2, CH3, and CH4. Four diodes D1, D2, D3, and D4, and it is the armature of DC circuitry excited motor armature. Okay. So current flowing through this armature is IA. It is in direction. We are assuming that current is flowing in this direction, and voltage across this armature is V. Okay. So we are assuming voltage across this armature is V. So we will see all the four quadrant one by one. So first we will start with quadrant 1, that is forward motor. Okay, so this is forward motoring mode. So for this we will operate switch 1. Switch will be switch 1 is operate, is turn on. So for first quadrant, for forward motoring, we operate CH1. Okay. So we turn on this switch. So this will be like this. Please turn on. So this will be like this. This will operate VS. Okay. Now this will connect the armature of motor. Now here C2, CH2 and CH3 will be off. CH2 and CH3 are off. They are in off position. And C3, CH4 is turning on. Okay. So current IA will rise from source. It will flow through this switch will close. Okay, CH1 will close. So current will flow through this and then goes to the armature and then it will come down with help of this CH4. Okay. So CH4 is also closed like this. This is CH4. So IA will flow. So the path of this IA will be from CH1 to RA to LA to back EMF, then CH4 and back to the source. So current will flow in the direction like this. Okay. So current is flowing in the same direction which we have assumed earlier. So current will be positive. So IA is positive and voltage across armature which is plus minus VA. So this will be equal to this is plus minus. So voltage, so motor is connected to source to switch CH1 and CH4. Okay. So voltage across armature will be equal to supply voltage P, which is positive. Okay, so IA is positive and VA is positive. So IA is positive and VA is positive. So this will operate in quadrant. Okay, here CH1 is operated, CH4 is on, and CH2 and CH3 are turned off. For quadrant 1. Okay. So this will be the case for quadrant 1 for forward motoring. We will switch on this stopper switch 1 and stopper switch 4. So current will travel to the circuit, will flow through the circuit. Okay. So here this inductor will be charged to this IA and current of the inductance voltage will be like this. Okay. What happens if C1 is turned off? C1 is off. Okay. So we are opening this switch. So what will happen if C1 switch is off? So this will be open circuit. So this armature will be no longer connected with supply voltage. Okay. So if you want to break, you want to stop this motor, we are opening this CH1. And one thing, CH1 and CH2 cannot be operated simultaneously. Okay. So switch C1 and C2 cannot be separately simultaneously operated turned on, because if this CH1 and CH2 is closed, then this will be short. This will short circuit the supply voltage. Okay, so we don't we don't operate this switch CH1 and CH2 simultaneously. Similarly, you can't operate this CH2 and CH4 simultaneously. If these two switches are operated simultaneously, so this will be short circuited and again source will be short circuited. So we have to make sure that these two switches should not operate simultaneously. Okay. Now we have disconnected this switch CH1. So CH1 is open like this, and So we have left with this CH4. Okay. So CH4 is coming on. So this is CH4. Now, the energy stored in this LA during this process will be discharged through diode D2. Okay, so this will mean D2 will start conducting and current IA will flow like this. Okay, so when C1 is turned off, then CH4 is on and D2 conducts. And this current IA will free will through this diode D2. Okay, so the energy stored in this inductance will be free will through this circuit, this closed path. Okay, and this will be short circuited. D2 will be short circuited. This current. So this current will decrease here. Okay, so this is the condition when this is again the current is in positive direction, it is in this direction, so current is positive, and VA is here VA is equal to 0. So here, so this will again operate in first order. Okay, now if you want to stop this motor. Okay, so this will be in second division. So second division, so second forward regenerated braking. Okay. So next we will see forward regenerative braking. So for this we operate C2. Okay, so here this motor is disconnected from supply when we open this CH1. Okay, so now CH2 will be turned on. This is the case. Here supply voltage is open. So now this will be closed. Now this CH2 is closed. Okay, so we are operating CS2 is operated. And then the current will reverse because current is flowing. The CS2 is open. Okay. So this is CS2, and the only possible direction circuit that IA can flow is this D4. Okay, so this current will flow free D4. Okay. So this is IA will flow. So current I4, IA will start conducting. So will flow to switch 2, then V4, E, LA, and RA. Okay. So current will flow like this. So when C2 is operated, then D4 conducts. Okay. So here we are increasing the generated voltage of motor. Okay, because it is regenerative braking, so this motor will behave like a generator. Okay, because we are charging this LA. Okay, so IA will charge this LA and it will store some energy, and voltage of motor will be equal to E plus LA DI by dt. So this is increasing. Okay, so the generated voltage of armature of motor is increasing as we are charging this inductor, and voltage across this inductor is LADI by dt is increasing, and plus IA. So this will be voltage across motor. Okay, and this will become greater than supply voltage V. This will become greater than supply voltage V, and this motor will behave like a generator. Okay, so that's why it is known as forward regenerative braking. Okay, here supply is not connected with the motor. Okay, so we have to stop motor. So in case you have to stop this motor. Okay, so this switch is one is off, and this is off. CH4, CH1 is off, and now this LA will charge in magnetic form. Okay, and then voltage across this motor will become EA plus IA DI by dt, and which will become greater than V, and it behaves as a generator at this time. Okay. So here other switches, that is CH1, CH3 and CH4 are turned off. So in this case, current is reversed. So we have assumed that direction of IA is like this, but current is flowing in reverse direction. So current is reversed. Current is negative or reversed. But voltage across armature is same. Okay, so voltage here voltage is 0. So when so voltage across armature is this much, and so IA is negative, so it will be in second quadrant number 2. Okay. So now when we turn off, CH2 is turned off. CS2 is turned off. Okay. So we are opening this CS2. Okay. So it is turned off. CS2 is turned off. Okay. So now the only possible path which can current flow is this from D. Okay. So So now current will start flow through this. So V2 is open and C1 is open. So current will flow like this. Again in negative direction. Okay, and uh, this LA will discharge. Okay, and here voltage is given back to the supply voltage. Okay, so that's why this is known as regenerative braking. At this time, as in case of generator, uh, generated voltage of motor will be equal to source voltage. So here generated voltage is greater than Vs. So it is working as generator. So mechanical power stored in this generator is converted in electrical and it is become more charged than this source voltage. Now this source voltage become load to this motor. So this is generator and this is load. So the energy will be given back to this source voltage. Okay. So at that time, this will behave like a generator. Okay. As generated voltage L di by dt is greater than source voltage. Okay. So this will behave like a generator, and this will give back power to the source voltage. Okay. So that's why it is known as regenerative braking mode. Okay. So when C2 is off, diode, sorry, this is D1, D4 and D1, D1 and D4 conducts. Okay, but in this case, motor is not stopped. Okay, so it is running due to its inertia. So only we have taken the supply. So we have to stop this motor. Okay, so we will see third mode, third quadrant. In third quadrant, it is reverse mode. Okay. So in reverse motoring, we have to reverse the direction of the motor. Okay. So this will be the case, and here the polarity of E will be reversed. This will be like this. Okay. So when reverse motoring mode, we operate CH3. CH3 is operating. Okay, so we will operate CH3. So we are closing this switch. So we are turn on CH3. 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 CH3 is good. And when CH3 is closed, so current will start flowing from CH3, and only path where this CH3 can flow is by closing this CH2. Okay. So we will turn on CH2. Okay, and current will flow like this. Since the current direction is changed, the polarity of E is also changing. Okay. So here, polarity of E will be like this. And here, current is again flowing in opposite direction what we have seen here. So IA will be negative. IA is negative or flowing in reverse direction. So this will be the case when CS3 is turned on and CS2 is turned on. Okay, and the current will flow like this. It will flow from CS3, PLA, CS4, and again back to B. Okay, and here, so which voltage is equal. So uh, voltage across armature is also negative. So here VA is negative and IA is negative. So this will operate in third quadrant. And here this inductor will charge through IA and polarity of this inductor voltage will also reverse. This will be minus and this is plus. Okay. Now what happens when CS3 is turned on? Okay. So now CS3 is turned on. CS3 is turned on. And CS2 is still on. Okay. So the only possible path where the current will flow through CS2 is if D4 is conducting. So D4 start conducting. And current will flow like this. Okay. Now this current IA will free will through this beginning curve D4, and the energy stored in this LA will be uh, dissipated through this resistance. Okay. So this energy will decrease and IA will also decrease, and this will feed will through this fluid. Okay. So now this IA will flow from CS2, then D4, then E, then LA and RA. This will be the case when CS3 is low. Okay. So again here your IA is negative. Okay. So this will operate in third quadrant. So when CS3 is operated, CS2 is on and CH1 and CH4 are off. Okay. And when CS3 is off, C2 and D2 conducts. D2 starts conducting. So the current will flow in this direction. Okay. So as current is negative, torque is also negative, and this will be in third order. Okay. So now last mode reverse regenerative. So reverse regenerative braking mode. Here we will operate CH4. CH4 Okay. So for each quadrant, the first quadrant CH1 is operated. For second quadrant CH2 is operated. For third quadrant CH3 is operated, and for fourth quadrant CH4 is operated. Okay. So for different quadrants, different switches are on. Okay. So when reverse regenerative braking. Okay. So again here this motor will behave as generator. So here we are switching on this CH4. So CH4 is start conducting. We just turn on CH4. So this is CH. So when CH4 is start conducting, so the only path of current which can flow through is through D2. Okay. So D2 will start conducting like this. CH3 is open. So when CH4 is operated, D2 conducts. D2 conducts and CH1, CH2 and CH3 are off. These three switches CH1, CH2 and CH3 are off, and current will be in this direction. So it will flow to RA, LA, E, CH4 and D2 like this. Okay, and again it is in the same direction of the IA which we have assumed is going into the armature. So this here IA is positive. In fourth quadrant IA is positive. Okay, here IA is positive. Okay, and again this inductor will start charging. Okay, so this inductor will store energy in form of magnetic form. So this IA will charge this inductor, and again back EMF and voltage across inductor will be greater than source voltage. Okay, so we are charging this inductor, so we can give supply back to the this source. Okay, so at that time this will behave like a generator. So this is a regenerative braking. So this motor will behave like a generator. Okay, so this will be same as in case of quadrant 2, but here it is operating in positive direction, but here we have changed the direction of the motor. It is rotating in reverse direction. Okay, so voltage is reverse here. So voltage is negative, VA is negative. Okay, so this is the case. Current is positive and VA is positive. VA is negative. So this is operating in quadrant 4. Okay, so this inductor will get charged to this IA. and voltage generated across armature becomes greater than V. Okay, so when this voltage across armature becomes greater than supply voltage, it behaves like a generator. Okay, so what will happen is when we switch off T4 is the okay. So this switch 4 is turned off. So we have opened this switch. Now this IA is flowing like this. V2 is conducting this short circuit. So the only path. So now current is flowing like this. I2 through armature. This is open. So only path through which this current can flow is D3. So D3 start conducting. So current IA now flow like this. Okay, in the direction same as in case of we have this way. So IA will go like this, and here D2 and D3 are this. Okay, so CH4 is open. Now only two diodes D2 and D3, and this voltage across armature is greater than VA. So again, this power will be given back to this supply voltage. Okay. So motor is running in reverse direction and is behaving like a generator. It will give back the generated power back to the supply. So this is known as reverse regenerative braking. Okay. So we have to increase this voltage so that the source become low to this generator. So we have to. That's why we have connected into D2 to increase the voltage across armature. This inductor. Okay. So when this voltage across inductor increases, so it exceeds this supply voltage V. Okay. So the motor will run in fourth quadrant as current is in opposite direction and voltage is greater than V and it has negative voltage. Okay. So this is all about fourth quadrant chopper. Okay. So in fourth quadrant, when before is turned off, so all the switches CH1, CH2 and CH3 are turned off. Okay. So this is fourth quadrant operation. Okay. So here we have two type A choppers, type A, type or type C choppers, and this is your type B chopper. This is also known as type B chopper drum. Okay. So here, what is going on? So first, we will turn on the CH1. So this will when CH1 is turned on, then this is completed. So motor works in first quadrant. That is forward mode. Okay, so CH1 is operated is forward 1 forward mode. Okay. So when CH1 is turned on, okay, so the armature current will rise to CH1 and then to armature, and only possible path where this current can flow is through CH4. Okay, so at that time CH4 is short circuit, is also turned on, and current will flow through source CH1 armature and CH4 and then goes back to V. Okay, this is the path for forward opening. Current is going in same direction which we have assumed. So here is VA and it is IA, both are positive. So this will work in forward opening. So CH4 is on, C2 and C3 are turned on. Okay, so for forward motoring, CH1 and CH4 will conduct. Okay, and C2 and C4 will be turned off. Okay, and current will flow like this. When we off this CH1, okay, CH1 is turned off. So when we so it is disconnected with supply and CH4 is turned on. So C2 is turned off, and only path where this current will flow with this D. Okay, so current will flow to this circuit from CS4, D2 and this armature. So then D2 starts. This is CH2 is. So this is the energy stored in this array will be discharged to this speed driven diode. Okay, so this is in that here. Now for second quadrant operation, second quadrant, CS2 is operated. So when CS2 is operated, so this is short circuit. Okay, and so when it will flow in this direction, CS2 is short circuited. So the only path the current will flow is through D. Okay, so current will start flowing in reverse direction. What we have assumed earlier. So this will be like this. Current will flow through like this from CS2 or D2 or D4, then E, LA and R. Okay. So this will flow like this. Okay. So D4 conducts, and all of these switches CH1, CH2 and CH4 are on. Okay. And we are charging this inductance. Okay, so this will store kinetic energy. And now, when CH2 is turned off, okay, so now we are opening this switch. So now current is flowing like this to D4. So this can flow through only D1. Okay, so D1 start conducting. So here D1 and D4 conducts. So all the switches are off. So D4, so this current will start flowing through and it is okay. So when switch CS2 is turned off, so this is D1 and D4 conducts, and here the voltage exceeds voltage across armature exceeds supply voltage. Okay, so it will give energy back to the source. Power is given back to the supply source. So this will become as a generator. This will behave like a generator, and this will give energy to this supply voltage. Okay, so this will act as load to this generator. Okay, so this case, your D4 and armature and D1 and current will be like this. Okay, so this will be the path of the current. Okay. So third quadrant, we have to reverse the direction. CH3 is operated. Now CH3 is operated. Switch. So CH3 is on. So CH3 is on. But the only switch which can be is CH2. So current will flow to the source, then CH3, and then CH2. And here again this LA will get charged. Okay, so it will get charged. So this current will flow again in opposite direction. Okay, and here rest C1, CH2 and CH3 will be on. CH1, CH2 is on. Okay, so from B to CH3 to armature and then this CH2. Okay, so current will flow like this. The current is always in negative direction, so this will be in upward. And when CH2 is off, it is turned off. Okay, here your CH2 is turned on. Okay, so only D4 can conduct. So again, this will be the direction of the will flow in this. Okay. So when CS3 is turned off, so C2 is on. So the current will flow through this D4. So D4 start. So energy stored in this armature will get discharged through freewheeling diode. Okay. And last condition, when CH4 is operated, when CH4 is operated, and here, so the current can flow through D2 only. The possible circuit current can flow through D2 only. So D2 will conduct. Okay. Now current will flow like this. So this is in positive direction. So IA is positive. So here it will flow in this direction through CH4, D2 and armature. Okay. And here all the switches C1, 2 and 3 are closed. Okay. Now again this LA will get charged and armature and voltage across this armature become greater than this source voltage. Okay. So when C4 is turned off, C4 is turned off. Now the only possible reason path where this current can flow is through VP. Okay, so this current is start flowing through this V3 and back to the. This will be the pump. Okay. So current IA will go to so current is in positive direction and this voltage is greater than supply voltage, so it is behaving like a generator and this will give back energy to the source. So this is known as regenerative braking and motor is operating in reverse direction. Okay, so this is known as regenerative braking. Okay, so this is all about four quadrant chopper. Okay, any doubt? Okay, so I am ending this class.